let's talk a little bit more about the Condorcet winner. That's what we were talking about at the very end last time. So I will refresh your memory about the definition of this. It says a candidate who would defeat every other candidate in a one-on-one comparison is called a Condorcet winner of the election. Now, depending on what system you're using, the plurality or the ranked choice, like this, such a person might not actually win the election, but they are still called the Condorcet winner. It means that that person would have defeated anybody else in a one-on-one comparisons. And the standard example, I think I said this last time, was the Bush-Gore-Nader thing. It's the vote totals in that example, remember, looked like 2.9 million said Bush-Gore-Nader, 2.9 million said Gore-Bush-Nader, and 0.1 million said Nader-Gore-Bush. And if we compare them in pairs, this is what I mean by a one-on-one comparison, you pair them up. And in this situation, there's three ways to do that. You could do Bush versus Gore, you could do Bush versus Nader, or you could do Gore versus Nader, right? And if I do Bush versus Gore, I'm going to count up votes which prefer Bush versus votes which prefer Gore, and I am temporarily ignoring the Naders. So here when I compare Bush versus Gore, I got 2.9. These people, they like Bush better than Gore, so those count for Bush. 2.9 here. The middle column, they like Gore better than Bush, so those count for Gore. And the final column, these people, ignoring the end, they like Gore better than Bush. So this 0.1 counts for Gore. And so I get 2.9 for Bush and 3.0 for Gore, and so Gore wins. Maybe I'll just circle the G here. Gore wins in that little matchup. And then you can do all the same stuff. I did this at the end last time. If you compare Bush versus Nader, it's going to say Bush gets 5.8 and Nader gets 0.1, and so Bush is the winner of that comparison. And if you go Gore versus Nader, actually get the same numbers. Gore gets 5.8, Nader gets 0.1, and so Gore wins that comparison. Now, Gore won twice, but Bush won once if you look at these individual comparisons. But I will note, is there, so what I'm talking about at the top there, a candidate who would defeat every other candidate in a one-on-one comparison. Actually, in this example, Gore fits that description. Because Gore versus Bush, Gore wins. Gore versus Nader, Gore wins. That means Gore versus anybody, Gore would have been the winner. All right. The fact that Bush won in this comparison is not entirely relevant because Gore is not even an option in that individual comparison. So here, Gore wins all his matches. So Gore is a Condorcet winner. Right. Doesn't mean he won the election, because he didn't, but this is what we call a Condorcet winner. Any question about the setup here? I thought we should, can we say something a little bit kind of abstract, theoretical? Would you mind? We're not going to do a whole lot of this during this semester, but I have a theorem about Condorcet winners. A theorem is something that, like mathematics, is all about theorems. These are true facts that you can prove logically. That's what a theorem means. And I have a theorem about Condorcet winners. It says, in any election, there cannot be more than one Condorcet winner. I should capitalize. Condorcet winner. This is a true fact. There cannot be more than one Condorcet winner in an election. It's a fact. And what you do, what mathematicians do is try to figure out theorems and then write a logical proof of them. Now, we're not going to do a lot of proofs in this class, but I felt like this is a math class, so we should at least talk about a proof of something or other every so often. So I want to talk about how would you prove this? I would write the word proof and underline it. We are going to, this is probably something that you've done like in a, I don't know, people do proofs like in high school geometry classes a lot. I am going to do a little argument by a contradiction. This is something that I hope that you've heard of before. So I'm going to say something like, to get a contradiction, let's say imagine, we had two different Condorcet winners. Let's call them A and B, right? And both of them are the Condorcet winner. You have to sort of fill in the blanks here. The way that this contradiction type logic works is you make this assumption and then you somehow explain why this is going to be impossible. So I'm going to sort of, don't write this down, but I'm going to say, you say a bunch of stuff here and then you conclude, this is impossible. So two Condorcet winners cannot exist. That's the idea of how we're going to make this happen. We got to fill in the blank. And it's not that hard in this case to fill in the blanks here. Can anyone see, like, you don't have to say this in a very highfalutin way, but what would be the problem if you have two different candidates, let's say A and B. This is a sloppy looking A. And both are a Condorcet winner. Remember, Condorcet winner means you would win in any matchup against anybody else. Anybody see the problem here? The situation is, I am imagining that there are actually two different candidates, and both of them would win in every comparison against everybody else. That, in something about that doesn't make any sense. Yeah.
Would it be like one winner?
Say that again?
There wouldn't be like one winner? Like, since there's two, they'll always win compared to everybody else.
Yeah, something is weird about saying there are two different people and both of them would always win in every comparison against everybody else. Can someone say, like, maybe a little more specifically, what's wrong with that? You should feel like only one of them is able to, yeah.
They can't like win against each other.
Yeah, to be very specific about it, you could ask yourself, okay, what's going to happen if I go A versus B then? Well, according to what I said, both of them are supposed to win in that comparison, and that's not possible. I think this is what she was getting at. So that's what I'm going to say here. What specifically is impossible about this is that you have to imagine what would happen if I did A versus B. So imagine we had two different Condorcet winners, say A and B. I will say then when we do A versus B, A must win because A is a Condorcet winner. Is a Condorcet winner. But also B must win for the same reason. And this is impossible, etc. The rest of what I said. All right? This is a bogus situation. You can't have two different candidates who would always win against everybody else, because at some point they have to meet each other and then they can't both win in that matchup. All right? This is just a cute little fact about Condorcet winners. There cannot be more than one Condorcet winner. And this, I didn't say this part last time, but this is why we can create what I called, so this is the last thing that I said last time, a new voting system. That is a new method for choosing the winner, is called the Condorcet method. And that is to find the winner, do all of the one-on-one comparisons, and then find the Condorcet winner. and then you just say that they win the election and declare them as the winner of the election. This is called the Condorcet method, or Condorcet's method, something like that. All right? It's totally different from the ranked choice where you do a bunch of rounds. This is, I suppose you do a bunch of like one-on-one rounds if you like, but they're not like elimination rounds. You just make all of the one-on-one comparisons. And of course, this is more complicated than doing the plurality system. The plurality is very easy. All right? You do all the one-on-one comparisons, find the Condorcet winner. Now, an immediate objection to this will be, well, what if you get two different Condorcet winners? And this is why I just said what I just said. That we now know there cannot be two different Condorcet winners. So this method will actually give you only one winner, which of course is what we want when we try to do this in real life. All right. Excellent. Let's try some examples here. So one thing that we can say already is in the Bush-Gore Nader election, Gore is the winner using Condorcet's method, right? Because, we said this last time, and also what I did at the very beginning today. We do each of those comparisons. There were 3 comparisons in that case. And you can see that Gore wins every time when Gore is involved in one of those comparisons. And so Gore is the winner using the Condorcet method. All right? And this is like a new method that we're going to, so your next homework assignment will have some examples, and it'll say, find the winner using the Condorcet method. So this is like the third, I guess. We have the plurality, the ranked choice, and then this one, the Condorcet method. All right? Let's try another example. So this is just a made-up example here. Let's try, how about this? This has 4 voters. You can see the Condorcet method is kind of a pain to do when you have 4 voters. C, B, D, A. Actually, this is the same example. We've done this example. I don't know if you care, but if you look back in your notes, you will see we did the plurality and the ranked choice in this example last week, I guess. One person said C, D, B, A. All right, here's an example. I would like to find the winner using Condorcet's method. I will just refresh your memory. If you look back in the notes, you will see this. In this example, if you do plurality, the winner is A, and if you do the ranked choice, the winner is D. We did this a few times ago. Let's try to do find the winner using the Condorcet method. So what we need to do is compare all of the pairs of candidates. Since there are 4 candidates, actually there are kind of a lot of different ways you could pair them up. And I'm going to let's just try to write down all the different pairs to begin with. I'm going to try to be kind of systematic about this. So let's start with pairs which involve A. I could do A versus B. I'm going to leave a little space because each one of these you have to count up the votes. I'm also going to do A versus C. Also A versus D, right? Those are all the pairs which involve A. That's just A versus each of the others. Now I could do a bunch of pairs which involve B. I could do B versus A, but I already wrote A versus B, so we don't have to do that one. But then I could do B versus C and also B versus D, right? Those are the ones which involve B, other than the one I already wrote at the top there. And then finally, I could do ones which involve C. I already wrote A versus C, B versus C, but you could also do C versus D. And I think actually that's it. These are the only ways of pairing up these candidates. I wouldn't really suggest that you memorize this, but it is a fact. If you have 4 candidates, there are 6 different ways that you can pair them up, and these are the ways. All right. Anyway, for each of these 6 ways, we have to count up the votes, and this will take you a few minutes to do. It's a bit of a pain, but we can handle it, right? This is college. A versus B. Okay, so what I'm doing here is, this can be a little confusing, but I'm looking at this chart, in each column, comparing only the A's and the B's, and I am ignoring the C's and the D's throughout. So these 14, they go for A because A is above B for them. So A gets those 14. The 10 column, is that for B or A? What do you say? B, yeah. The 10 column has B above A, and so I put 10 in the B. The 8, I see B above A in the 8. So that's a 8 for B. In the column with 4, I see B above A again. So that's 4. And the 1, B above A. All right, so you add these all up. I have 14 for A, and whatever that is, it's more than 14, right? 23, I think. So B is the winner of this comparison. All right. I hope that makes sense, what we just did. We just got to do that again 5 more times. This is a pain, but I mean, it's not really hard. It's just, you just got to do it. All right, so A versus C. All right, again, we look down each column and count them up for either A or C, ignoring B and D in this case. So the first column is 14. I see A on top, so A gets the 14. The next column, C versus A. C is above A, so C gets those 10. The next column with 8, again, I see C is above A. The next column with 4, again, C is above. And the next column with 1, C is above. So that's a 1. So this also adds up to 14 and 23, and C is the winner here. All right. Let's keep it going. A versus D. I think actually the same thing is going to happen with A versus D. A wins in the first column. A is above D. But in all other columns, D is above the A. You have to check that. But you can see A is actually on the bottom of all the other columns. So D is above the A on the other one. So that would be, again, 10 and 8 and 4 and 1 in favor of D. So this, again, is 14 to 23. D wins this comparison. All right. I hope everybody sees how I'm doing this. How about, can I have you guys try the other? There are 3 remaining comparisons. See what you think. I will write my answers kind of slowly here. See if you agree with my numbers. B versus C. These ones are not all going to be the same. I'll give you a couple moments. All right, can we talk about them? I hope you got some, I mean, I'm not any better at adding numbers up than you are, so I may have screwed some of these up. But for B versus C, I got 18 for B and 19 for C. Anybody agree? Yes, so C is the winner of this comparison. B versus D, I got 28 and 9. They are nodding their heads, which means they agree. So B is the winner of this comparison. And C versus D, I got 25 and 12. And that means that C is the winner of that comparison. All right, I hope that everybody is good with where all the numbers come from. Now, at this point, I don't need to look at the chart anymore. Who is the Condorcet winner. Now, it's not immediately obvious when you look like some, I suppose it's not A. A never won, but what you're looking for is find the one which wins in all of their comparisons and never loses. Anybody see? I just gave it away. C, yeah, I said C. It's C. Because C wins here, C against A, C wins. C against B, C wins. C against D, C wins. All right. Now you might, in the back of your mind, worry about maybe also B has the same property, but it's not possible. We already said there can only be one of these Condorcet winners. So I will just say C wins all their contests. So C is the Condorcet winner. C wins if you use, what? C, can I say, I meant to say C wins using Condorcet's method, or whatever. You can say it either way. C wins using the Condorcet method. All right? This is how we do the Condorcet method. So maybe I'll just scroll back up here. I'll just add in here. The Condorcet method, C is the winner. All right? It's different from the plurality and the ranked choice. I don't know if you were wondering this in the back of your mind. Here's another thing you could have wondered. Is this somehow the same as the ranked choice? I mean, like when you do the math, it doesn't look the same. But of course, everybody knows in a lot of math problems, there could be like two different methods which give you the same answer. And maybe this weird Condorcet method is somehow, for some abstract reasons, always going to give you the same answer as the ranked choice. But it doesn't, right? The Condorcet method is yet a third way of deciding the results of an election. All right? Excellent. So you'll have some more practice with the Condorcet method on the homework. I would like for us to try one more example. And maybe I'll let you guys try this whole one. I will walk around and make sure everybody's feeling good about it. You will see actually something weird is going to happen in this example. So here's a little sort of a bad news example. But I'll let you, no spoilers, I'll let you figure out what exactly is weird about this example. But let's say 12 people vote for ABC. 8 people said BCA. 7 people said CAB, and 2 people said BAC. All right, find the winner using Condorcet's method. See what you think. There's only 3 candidates here, so you're not going to have to do like all 6 of those comparisons. There's less than 6. Because there's only 3 candidates. I'll give you a few minutes and I'll come around. Please let me know as I'm walking around if this isn't making any sense. I'm happy to help out. I got 19 and 10 for the first comparison, so if you got that also, you're probably doing great. something slightly weird. We good so far?
Yep.
Yes. Okay.
Sir.
What is up? We good here? Great. Seems like people are doing pretty well. I'm going to write up what I got here. So in A versus B, I got A 19 and B 10. So A is the winner of that comparison. And then when I did A versus C, I got 14 to 15. So A had 14, C had 15. So C is the winner of that comparison. I hope you agree with these numbers. And then when I do B versus C, I got B has 20, C has 9. So B was the winner there. Anyone agree or disagree? I mean, as I was walking around, it looked like people got these numbers for the most part. All right. Now, I said that this was sort of a bad news example. Can anyone give me, like, what's slightly weird about this? Any conclusion? Yeah?
There's no winner.
Yeah, in this case, there is no single person who wins all of their matchups. This is a little weird, but A doesn't win all the time because A does win against B, but not against C. B also doesn't win all the time because B is beaten by A, right? And then C also does not win all the time because B beats C. So in this case, no candidate wins all their matches. And so that means there is no Condorcet winner. Sorry, I'm off the bottom. There is no Condorcet winner. We said before that there cannot be more than one, but actually there can be less than one. There can be like 0 candidates who win all of their matches, all right? So there is no Condorcet winner. What this means, if you think about using this method in the real world, this is why none of you have ever heard of anywhere where they use this method in the real world, because in politics, we don't use this method for exactly this reason. So in real life politics, now you can do this method in other contexts, but in politics, we don't use the Condorcet method because often there is no winner. And in that case, you know, there are some situations where you can try and vote on something and then decide, oh, I guess nobody won. And that, like, sometimes that's okay if the vote you're doing is not very important. But if you're, say, electing the President of the United States, you would not want to use this system because sometimes it would just say, well, nobody won. And then what are you going to do? Not a great system to use in real life, sort of high stakes political elections. All right, I meant to say we don't use the Condorcet method. I left out the word. We don't use the Condorcet method in politics because often there is no winner. You could say in such a situation like it's a 3-way tie or something, but this is not satisfying in real life. All right. Any thoughts about that? I think actually, like, if you have somebody who is the winner using Condorcet method, then that's a pretty strong statement about that person actually being somebody who everybody really likes. But oftentimes you don't get a winner, and so this system is not really appropriate for real life usage. All right, let's try. We got 20 more minutes. I got another system to talk about. Would you mind? How about one more? One more voting system. This is something that I'm sure you are all familiar with. Actually, I have seen ranked voting is sometimes used. Well, let me just describe the system, and then I will tell you how you may have seen this before. This is called the Borda count. This is named after this guy Borda, who was another. I think Borda and Condorcet lived around the same time. They're like old school 1800s French guys. This is where this kind of voting stuff was first taken really seriously by European mathematicians. This is called the Borda count, and this is a system that I think actually any of you could come up with if you talk to kids about voting. It is a natural thing to suggest. The idea behind the Borda count is each position in the ranking, gets a certain amount of points. And then you add up everybody's points. All right? This is called the Borda count. This is used a lot in the real world, not so much in political elections, but it's used in situations when you have rankings and then you want to somehow take all these rankings and decide who's the best overall. This kind of Borda system is used very often. Can anybody think of something in real life where they use this? I have a few examples in mind. Something where you get a bunch of rankings and then you have points for each one and add them up. One thing I can think of is my younger kid is a freshman in high school, and she's on the swim team. And when they have a swim meet, they actually score the swim meets according to a system like this. So they have like 20 different individual races, and some people come in first, second, third, whatever, and your team gets a certain amount of points. If one person finishes first, I think you get 5 points, and then if you finish second, you get 3 points or something like that. And then they just add up all the points. Like a lot of sports type tournaments or whatever, they work in this same way. I think the World Cup works something like that. If you win, you get 3 points if you win and 1 point if you tie, something like that. And then you add up all the points, and that's how you decide. So this is, I would say, common in the sports. All right, that's not exactly voting though, but you can do the same thing when you're voting. That's what I'm saying. All right, this is how it's done in. I don't know much about sports myself. I don't know if you can tell from my general demeanor. I'm not like a sports bro. This is also used in. I happen to know a little something about Mario Kart. This is how you decide who wins the trophy at the end. Each individual race, depending on which position you come in, you get a certain amount of points, and then they add up all the points. I will say, etc. Right? Can anybody think of any other situation where they do this? It's a reasonably common sort of a thing. Actually, if you do, there are a fair amount of online. I have seen often online polls or something. They are usually scored in this way. If you want to vote for rank your top Taylor Swift albums, and then somebody will add up the results. I don't know if any of you have ever wondered, how do they actually add up those results? They could use the ranked choice voting system. They could try to do the Condorcet method. Usually such things use something like points, and so they end up being equivalent to the Borda count. All right, so anyway, this is common in sports, etc. I will say not very common in politics, but there are some places that use this kind of point-like scoring system in politics. But anyway, we'll discuss why. there's nothing obviously bad about doing this in politics, but there are some slightly technical reasons why this is typically not done in real life politics. But it's not a disaster if you it's not a ridiculous idea to try to do this in real life politics. There are some reasons why nobody does it. Anyway, can I just say we should be specific about how exactly do the points work? So there are, of course, many different ways you could decide to assign the points, but the standard way, and when I say the board account, I'm referring very specifically to the standard way of assigning the points. The points go like last place is 0 points. Second to last is 1 point, etc. So you just get like one more point for each position you are above the last place ranking. There is no bonus for coming in first. Some of these point systems like give you a little boost if you come in first. They give you an extra point or something like that. The standard board account does not work like that. So it's just the last place gets no points, the second to last gets 1 point, and so on. So if there are, it's a little ambiguous if you just ask me how many points do you get for first place. It kind of depends on how many total candidates there are, because you start with 0 in the last place and then you go up one more. So it depends on how many candidates there are, but we can say if there are n candidates, then first place gets, the points that you get go 0, 1, 2, 3 up to the top. The top, since you're starting at 0, the first place gets n minus 1 points. Because you start the points at 0, and when you count up to n, you'll be like 1 less. But anyway, this is, I don't know if it sounds complicated when I say it this way. It's not complicated at all. Let's just try an example. Sorry to scroll what I just wrote so quickly. I'm trying to get below the bar here. Let's say I have an election where one person votes A, B, C, D. Another one person votes B, A, D, C. And another one person votes C, D, B, A. All right? This is my election here. And let's try to find the winner using the board count. All right? I'm going to write another column for the points, just so we're clear. Last place is 0 points. Second to last place is 1, and then 2, and then 3, right? These are the points in this particular matchup. This, you can see very clearly this business about the n and the n minus 1. In this case, I don't know if that was confusing, but here we have 4 candidates. That's why first place gets 3 points, because that's 4 minus 1. It's 1 less than the total number of candidates. But anyway, we just got to add up all the points, right? So we add up the points. And, as usual, this can be a little bit of a pain just to do the numbers, but it's not really hard. So from the first, well, let's just go, A, B, C. How many points, and D. How many points does each one get? So A, from the first column, A gets 3 points because A is in first position in the first column. So 3 for A, plus in the second column, A is in the 2-point position. So that's 2 more points for A. And then in the third column, A came in last, so they get 0 from that one. So that's 0. So this is 5 points for A. All right. I hope it makes sense what I'm doing here. I'm adding up the numbers. All right, for B, in the first column, B is in the second position, so that's 2 for B. In the middle column, B is on top, so that's 3 points. And in the last column, B is in the 1-point position. 2 and 3 and 1, that's 6. All right. For C, I get 1 point in the first column, 0, and then 3. So this is 1 plus 0 plus 3. That's 4 points for C. And then D, it looks like 0 and 1 and 2, right? I hope everybody sees where I'm pulling these numbers from. That's 3 points. And so the winner is B here with the board count. Any questions about that? I hope it's clear where all these numbers come from. This one is, I suppose, in terms of like traditional kind of adding stuff together. This is the most intensive. You have to add a lot of little numbers to make it happen. Not so difficult though. All right. And what about, so this actually, unfortunately, this was an especially easy one because we had only one voter in each column. If you have more than one voter in each column, it can be slightly more difficult, which I would say is actually kind of a significantly more confusing situation. But let's try an example like that. BCA. All right. And again, the points here are 0, 1, and 2, right? It's always 0 points for last place, and then 1, 2, up to whatever. All right. I think actually, can I change this? This will be clear if the columns say 30 and 20. So 30 people vote A, then B, then C. 20 people vote B, then C, then A. All right. Now let's add up the points. This is more complicated now. So the points, I'm going to do the Borda, of course, is what we're doing here. So what are the points for A? Now, in the first column, A gets 2 points, but there are 30 voters who put A in the 2-point position. That means from the first column, A is getting 60 points. That is 30 times 2 each. All right, so I'm going to try and write this out in the most detail that I can. 30 times 2 from the first column, because they're getting 2 points on each of those votes, but there are 30 of them, and so you get 30 times 2. And from the second column, 20 votes giving 0 points, so that's 20 times 0. I hope you all remember your order of operations. When I write, this is like, this whole thing here is a mixture of multiplications and additions, but you should do the multiplications individually first and then add them all together. So if I were doing this, and this will not always work if you're using a very simple calculator, you can't just type this in order, you'll get the wrong answer. So beware of that. But anyway, if I do the multiplications first, maybe I'll just do it right here. That's 60 plus 0, and the total is 60. All right? This, by the way, I believe is the only time during the semester when you will have to multiply. My apologies for making you multiply. It's not going to get any harder than this, though. All right, those are the points for A. Let's do B and then also C, right? So by the same reasoning, B in the first column has 1 point each on 30 ballots. So that's going to be 30 times 1 plus, in the second column, 2 points each on 20 ballots. So that's 20 times 2. This is 30 plus 40, which is 70, right? And then I hope everyone agrees with my numbers. And then for C, same idea. I have 0 points in the 30 column, so that's going to be 30 times 0 plus 20 points, no, 1 point in the 20 column, so that's a 20 times a 1. This is 0 plus 20, and the answer is 20. And so the winner is the 70. B wins. That's how we do the Borda. Any questions about that? In my opinion, this is a very kind of a natural thing to do. Like I said, this is something that I'm sure any of us could have come up with this system. It's not overly complicated. It's not totally weird. It's pretty ordinary idea, in my opinion. All right. Let's see what would happen. We got 5 minutes. Let's see what would happen if we do this. How about Borda in the Bush-Gore Nader election? This is the example I always like to go back to just because it's fairly simple and interesting in my opinion. What if we had done the Borda in the Bush-Gore Nader election? All right, remember, I will refresh your memory. We have 2.9 million. I'm doing everything in millions, right? Say Bush-Gore Nader, another 2.9 million, say Gore-Bush Nader, and another 0.1 million, say Nader, Gore, Bush. All right, let's do the Borda in this case. The points, you should write down, the points go 0, 1, 2 in this case, right? And we just add them up. Bush gets 2.9 million times 2, that's the first column. So really what you're doing here is you are always multiplying the top of the column times the points for that position, and then you add them up. So 2.9 million times 2 points each. The next column, 2.9 times 1 point. So this is plus 2.9 times 1 plus the last column, 0.1 times 0 points. Right? And if you add all of this up on your calculator, 2.9 times 2, that's 5.8 plus 2.9 plus 0. And if you add that up, I got 8.7. That, of course, means 8.7 million points for Bush in this election. All right? By the way, when I do this in class, I'm going to write out all of this detail. If you are able to do some or all of that in your head, I don't think you really can in this example, but if you want to do it in your head, that's totally fine with me. You should still write down the totals, I suppose, on your homework or whatever, but I am writing the most possible detail. You don't always have to write the most possible detail. Let's do Gore. That would be 2.9 in the first column, 2.9 million times 1. It's always the number up top times the point value in this position. That's a 1 point. Here, 2.9 times 2 points. So that's 2.9 times 2. And then the last column is a 0.1 times 1. And if you add this up, it's a 5. Well, this is 2.9 times 1 is 2.9. 5.8 plus 0.1. This adds up to 8.8 million points for Gore. All right? And so you can see here, actually, Gore is going to win this election rather than Bush. Right? Gore has slightly more points because of that last column, really. Although, for completeness sake, we should add up the points for Nader. I mean, Nader's never going to win. But let's just, for the sake of doing it, Nader in the first column, 2.9 times 0. In the middle column, another 2.9 times 0. And in the last column, 0.1 times 2. Hey, how about that? This is 0 and 0 and 0.2. So 0.2 million points. A poor showing, as usual, by Nader. All right. So the winner, anyway, is Gore, right? 8.8 million. So Gore wins using the Borda. In case you're keeping score, in real life, Bush won using the plurality system. But if we had used basically any other system, Gore would have been the winner. If we used the ranked choice or the Condorcet or the Borda, Gore wins in all of those situations. All right. We'll do another example next time and then go on to something a little different. We will have homework to do over the weekend, as always. See you next time.